going to look at how the resistance of different resistors combines depending on how they are arranged. First, I'm going to create a circuit that only has the resistors in in series. I'm going to put 3 resistors in. Let's say our battery is 30 volts. We're going to call this a 2 ohm resistor. I'm going to say that this is 5 ohms and this is 8 ohms. What makes this series rather than parallel is as the current travels, there's no branching, and after going through the 2 ohm resistor, we'll go through the 5 ohm resistor, then through the 8 ohm resistor, and back around. When you have resistors in series, you simply add them up mathematically. However many resistors there are in series, you add those values. So here, 2 plus 5 plus 8 gives me an R net equal to 15 ohms. This circuit is the same as if I drew this circuit. I mean, not exactly the same, but if this circuit has the same current as that circuit. This circuit will have the same power as that circuit. For this particular example, I could ask you these questions. I could ask you to find R net. I could ask you to find I net, or if I just say I, it probably means for the whole circuit. I can also ask you to find the power. So R net, we already found, is 15 ohms. If I want to find I net, I'm going to use Ohm's law. V equals IR. I know the voltage to be 30. I'm looking for I. R is 15. I gives me 2 amps. For power, this formula is new. It's also written in your notes there. The formula that I tend to use for power is P equals I squared R. If I'm looking for the power of the whole circuit, I use I net and R net. If I was trying to find the power of a given resistor, I would use its current and its resistance. And that's going to be an important point that we'll see later. So the current for the whole circuit is 2 amps, squaring that, times R net, which is 15. 4 times 15 gives me 60. And if you remember from earlier this year, power is measured in watts. Next, we'll look at combining resistors in parallel. Let's look at another really simple circuit, this time with the resistors in parallel. So parallel means I have a split. And some of the current is going to go one direction, and some of the current is going to go the other direction. I'm going to make this a 10 ohm resistor and this a 40 ohm resistor. And I'm going to have a 24 volt battery. I thought about these numbers ahead of time so that they're going to come out nicely for us. Current, and then we get to this point, and some goes that way, and some goes that way. So we're going to do sort of the same thing here. We're going to find R net, we're going to find I net, and we're going to find power. I'm combining resistors that are in series this time. I keep doing that, in parallel. When I have resistors in parallel, we add their inverses. However many of them I have will give me 1 over R net. So 1 over 10 plus 1 over 40 equals 1 over R net. I'm not getting a common denominator here. I'm literally just typing into my calculator. That works. 1 over 10 plus 1 over 40 equals blah, blah, blah. 1 divided by my answer to flip it, and I get R net equal to 8 ohms. In other words, this circuit can have a more simple equivalent circuit of this. The 10 and 40 ohm resistors can be replaced by an 8. So I found R net. I want to find I net. So I'm going to use V equals IR. Net voltage, current, R net, I is 3 amps. those 3 amps, if I wanted to back up here, leaving the battery are 3 amps of current. When I get to this point, some of the current's going to go one direction and some of it's going to go the other direction. Which one is going to be easier for current to flow through? Well, the one with less resistance. So if I were to calculate the amount of current in each one of these branches, I would find that this one gets 4 times more current than the other one. Or this one gets 1/4 of the current that the 10 does. We'll come back to that later, but I wanted to introduce it now. To get power, P equals I squared R, 3 squared times 8, 9 times 8, 72 watts. Our next circuit is going to be a little bit more complicated, and it's going to have some resistors in series and some resistors in parallel, and we'll look at how we simplify that.